Alrighty, so we're making our way down to one of our mineral claims, and what we're doing is we're finishing off some exploration we didn't have a chance to finish off 3 months ago. And what we have is a whole bunch of showings, a whole bunch of old workings on this mountain. We got a bunch of different claims up here, but this one thing that we haven't finished is sampling a mine dump by an old shaft. So a few months ago we showed a video on the shaft. We'll quickly show it again, and then we're going to sample the mine dump to complete our sampling program here, and we'll post say a result or two at the end of the video, so stay tuned for that. So we'll see you guys there. So you can see oxidization all over the rocks. You have a zone that's a kilometer and a half wide and 11 kilometers long, all in a line headed this way, and this whole area has mineralization. Spotty, some big past producing mines here, some current producing mines. The ones here, they're all past producers, but we're hoping to turn one into a producer. So over there you have a nice big quartz vein with mineral in it, disseminated, and solid mineral in the form of chalcopyrite. Good grade gold, silver, copper. Nice piece of float quartz. So over here you have the shaft and the mine dump down here. So we're gonna head over there and get to sampling. Okay, so we're coming up on a showing here we discovered. It's about 7 meters away from the top of the shaft. You can see disseminated mineral through quartzite and schists. So we pulled off some decent samples from here. That turned out to be high grade. Same with up here, and you have more mineral exposed up there. So obviously they left quite a bit of reserves here. Don't know the reason why, but we're gonna tackle that. Let's go take a look at the shaft. Okay, so here is the shaft. Water levels dropped about, I'd say, 1.5 meters since we were here last. Water actually looks a lot clearer. It's kind of oily and super rusty looking before, so maybe we can get down and actually sample something off the wall there. It was a little sketchy before. Here we have our mine dump. So we're gonna actually expose some of this and see if we can find anything worthy of sampling so we can finish this program. Alright, so something I just wanted to point out. I've seen a lot of comments on this. Sulfides, specifically sulfides that contain gold versus your rocks that contain free mill gold. Sulfides often have free mill gold as well. In this case here, your gold is found as a replacement element. So say you have your iron pyrite, which is sulfur and iron. You have several elements which replace some of the sulfur, or several elements that replace some of the iron. Say 5 parts per million of gold, then you now have a 5 gram per ton ore. So people always write off sulfides. If you did that, you'd be missing out big time. Sulfide deposits, in our area at least, they account for most of the minerals that are mined out. So definitely never write off sulfides. A lot of the deposits around British Columbia, all sulfide deposits with really high grades. So in this case here, when we sampled this showing, we sent in a test, multi-acid ICP and fire safe for gold, and we came back with something that was around 1 ounce per ton gold. Mind you, you can't really see it, but doesn't mean it's not there. So a good way to do your testing is send it in for an analysis. It's not super expensive. If you send it in, I always recommend doing something like a 51 element ICP with an added fire safe for gold, or something that has multi-elements so it covers all your elements. You could add precious metal packages on there. So what we're going to do with this, we already know what elements are in here based on our previous testing. So we're just going to test for those ones. That way it'll make their test cheaper. So we've got some samples here from the mine dump. Again, this is mostly iron pyrite with a little bit of pyrrhotite and chalcopyrite. So your pyrrhotite, a little bit of chalcopyrite mixed in there, and then you have coarse-grained pyrite. Same with this sample here. So these are solid mineral samples. Solid mineral meaning almost all mineral with little or no host rock. Got a few more here. So you got a schistose rock with iron pyrite. Little bits of quartz in there. Again, similar here. And here you have some very coarse grained pyrite. So we'll mark which ones in the video we're going to be sending in for a test. We'll probably show a couple of them. This is the last and final stage for completing a sampling program here on this property. We've collected about 100 samples over this 6-cell tenure. So lots of mineral everywhere. This is one of the showings we discovered last time, and it's exposed up there as well. So we got some more samples here. I just wanted to show this thing really quickly. So you can see you have yellow. That is an indication of your sulfur. You can see you have your burgundy, rusty colored. That's an indication of oxides, your iron oxides. So right here we got a few samples from 2 separate rocks. I'm going to try and go in close so you can see. So you have slightly off-colored yellowish mineral in there, which is chalcopyrite. And you can see right there you have a piece of metal which is surrounded by a coat of oxidization or rust. So chalcopyrite, which is this, is a very stable mineral, and you don't often see very much deterioration that you would with your iron pyrites. So you can see obvious difference. So as these are some of the samples we got. Again, you can see this is more of a yellowish color here, and you can see the slightly iridescent color, which is the blue, a little bit of pink there, which also comes with your chalcopyrite. And then over here you have a more shiny, coarser, rusty mineral, your iron pyrite. So we got a few samples here. I think we're going to send one of these in for analysis. So this is all from the same rock here. These pieces as well. So I think what we'll do is we'll send in this. We'll post the assay results for that at the end of the video. Again, very deteriorated iron pyrite. With a little bit of quartz. So some of you may have heard me talking about vuggy quartz. This is a perfect example. You can see you have your quartz here. Very, very unstable and deteriorating iron pyrite is going to fall away from your quartz, leaving pockets where your mineral or iron pyrite used to be. So that is one way vugs are formed. All right, let's keep looking. All right, so that's going to complete our sampling. Prospecting partners over there sampling. We got 12 samples in total from the dump. Over here is the high grade pile. And that is the new showing that we kind of uncovered, dug off. May not be new, but it's definitely new to us and it's got a good grade. Over there we got some mineral. And up there, we kind of dug it out and we found another exposure with disseminated chalcopyrite. So we sampled in a bunch of different spots here. We basically took the average, we're going to take the average grade for this entire dump. And we want to combine the samples, send it in for analysis. So we'll see what comes out of this. We'll post that assay result after. And then we'll post the average assay for the high grade pile, which is right here. And then that single sample we showed you. So stay tuned for that. We'll post them right now. We gotta get out of here. Sun's starting to set, so till next time guys, happy prospecting.